My name is Dr. Yap Ban Ha, and I will share this problem with you. This problem is about our friend, Spiky. He was trying to do addition. He was trying to add two fractions. And he got this. He thinks that the sum of 1/2 and 1/3 is 2/5. But it is wrong. Our problem today is to explain to him why he is wrong and to help him figure out the correct sum. Let's talk about this with our friends. Today, you can choose your own materials. If you need concrete materials, you can use paper strips, you can use fraction strips, or you can choose not to use any concrete materials. You can draw, or you can do calculations. Today, you have a choice. Remember, when we solve a problem, we try to solve it in more than one way. Hopefully, you can get method 1 and method 2. And perhaps, on clever days, you might even get method 3. I wonder if today is a clever. Also remember, we agree to listen. We do not need to agree. Sometimes, when discussing things with our friends, we may have different opinions, different ideas, different solutions, different answers. That's all right. We agree to listen. We do not need to agree. Let us now try to solve the problem. Method 1. We can explain why Spiky is wrong by using fraction strips. We can see that this is half. This is 1/2, also written like that because there are two equal parts making one. So the name is half. And these are thirds. These are thirds because 3 equal parts make 1. 3 equal parts make 1. The name is third. So this is 1/3. And this is how we write it. And these are fifths. 5 equal parts make 1. The name of each is a fifth. So this is 1/5. This is another fifth. These are fifths. Method 1 to explain why Spiky is wrong. We can tell 1/2 and 1/3 is obviously more than 2/5. 2/5 is only this amount. 1/2 is already that amount, and plus 1/3, it is very clear that 2/5 is less than the sum of 1/2 and 1/3. It is clear that 1/2 and 1/3, the sum, is greater than 2/5. Can we also find out the correct answer? I have some fractions that are equal to each other for you. Are you able to use them to suggest a correct answer for the sum of 1/2 and 1/3? The problem with not being able to add them directly is because half and thirds are different things. Like apples and oranges. 1 apple and 1 orange never give us 2 apples nor 2 oranges. So we cannot really add things up when the names are different. So 1/2, the name is half. 1/3, the name is third. They are different kinds of things. Are we able to make use of any of this to help us suggest a correct answer? That is right. 1/3 is 2/6 and 1/2 is 3/6. 1/2 and 1/3 is also equal to 3/6 and 2/6. Now, these are all 6. So we can add them up as usual. 3 of this and 2 of the same thing give us 5. 5/6. That's the correct answer. Method 2. Some of us explain that Spiky is wrong by saying that half is already more than 2/5. And we can suggest a correct answer because we know how to get equivalent fraction. So we know that half is really 5/10 and 1/5 is really 2/10. So 2/5 is only 4/10 compared to half, that is 5/10. Clearly, half is already greater than 2/5. So it is impossible that you add 1/3 to half, you get 2/5. And we know that half is equal to 3/6 and 1/3. Can it also be written as a bunch of 6? That's right, 1/3 is also equal to 2/6. So the sum of half and 1/3 is really the sum of 3/6 and 2/6, and that of course is simply equals to 5/6. So we can suggest the correct answer for the calculation that Spiky did wrong. Method 3. Some of us think that the sum of 1/2 and 1/3, you will never get another fraction with denominator 5. Some of us think that that's just impossible to get a whole number of fifths when you add 1/2 and 1/3. Some of us think that the denominator in the sum of 1/2 and 1/3 can only be certain numbers. Because multiples of 2 among others are the following. And multiples of 3 include this. Some of us think that when you add 1/2 and 1/3, the denominator in the sum can never be 5. It must be a number from this list. In particular, some of us think that the denominator in the sum must be a multiple of 2 as well as a multiple of 3, which means the sum must have a denominator of 6 or 12 or 18 or any number that is a multiple of both 2 and 3. What do you think about that idea? Today is a clever day. We have different methods to explain why Spiky is wrong, and we have ways to suggest the correct answer. If you understand any one of the methods, you have understood today's lesson well. Dear colleagues, that is one way to present an anchor task. There are many ways to present anchor tasks, but whatever we do, make sure we provide students with the opportunity to learn whatever they need to learn through a single problem. To paraphrase Paulia, it is better for students to solve one problem in 5 ways than to solve 5 different problems. Provide ample opportunities at exploration before structured learning. That's from Dean's theory. Provide concrete materials. Provide visuals, pictorial representations before they move on to abstraction. That is Bruner's CPA approach. Make sure there's ample opportunities for interaction and conversation. That is based on Vygotsky's theory. Also, Piaget's idea of children using their own natural spoken language to grapple with abstract ideas. Focus on conceptual understanding rather than tricks, formula, procedures. That is Scamm's theory. In a structured discussion, you would expect the struggling learners to be able to come up with at least one method outlined in Method 1. For average learners, they should be able to come up with Method 1 and Method 2. And if they are advanced learners in the class, Method 3 and beyond are some possibilities for them to challenge themselves. In this video, we see how we can implement an anchor task and conduct structured discussion.